Hello and welcome. How's it going? How's it going? So, last stream we were doing some performance improvements on the traversal code when we traversed the BVH, and we got it down to about 0.72 ms from about 1.4 ms. So it was basically a 2 times improvement, right? And we did some other things as well, like had some features to debug, like some heat map stuff to debug how much we're traversing down and stuff like that. This stream we want to continue on the improvements for the traversal code. So basically I did this sort of summary here. So is that right? I'm not sure if I zoomed in already on the... Damn it. There we go. Cool. So let's just zoom in for everyone else. So this is basically the order we're going to go into it today. So we're going to make some part of the code branchless, but not branchless, right? So just branchless. We might have to have a small branch in there. I don't think this is going to be like an absolute massive win, but we're going to see something. It's just basically clean up the code as well. We also want to maybe predict the closest hit and basically set a variable in the code, which will allow us to skip a load of traverses in the skip checking a whole bunch of nodes while we're traversing down the tree. So we have a little check in the code, which basically says something like, if the bounding box of this node is further away than the closest hit, then don't bother going down this node. So we could potentially skip out on whole checks of things, right? Potentially, right? It could be quite low in the tree, but it also could be quite high in the tree as well. So that's gonna be a really big win for some cases, but there might be some other problems we'll have to solve with that. We'll have to see. There's another one where we could basically do a level of we could basically, yeah, it's kind of, yeah, we can basically render the boxes of the BVH. That's the basic idea with this one, right? Rather than going all the way down the tree, if the box of the BVH ends up being like kind of about, a few pixels big, something like that, we'll just render that instead. So we won't have to make a whole new model, right? If the model is small enough, we can just use the tree as the sort of best guess of what the model is, right? We'll see if that's a good idea. That's something we're going to try. And then we also want to make the number of spheres configurable at the base level. So at the moment we have 2 spheres on the leaf nodes. So what we want to do, so if you go down to the leaf node, you find there's 2 spheres, right? We want to make that configurable because maybe after you check the final box, maybe it's good to squeeze 4 in there because potentially where's a good case? It all depends, right? Yeah, maybe this is a really bad case for it. Yeah, potentially they're already next to each other anyway, type of thing. And maybe we can sort of solve this problem better by having gaps in the arrays. Yeah, so these 4 are basically next to each other. So when you sort of hit this box and then hit a sibling box, you're checking an extra box. Wait, you're checking an extra 2 boxes. You're just checking the parent box and then both the left and right sibling, or siblings, right? Sorry, left and right children. So we might as well just get rid of the 2 box checks and just check the 2 spheres. Now, I think we might make the number variable. So if the spheres are further apart or something like that, and the box is bigger, maybe we can. I'm not sure, but yeah, we'll see. We'll see how much of when it does increasing it at least. There's maybe some extra trickery we could do. But yeah. Right, so let's get started on some of this. So here's the branching code base. Oh no, this is not. This is the BVH viewer, which is the right. So this is the code here, the branchy code. So basically, you know, we do our for loops over 2 BVH nodes on the same two sibling BVH nodes, right? We just over these 2. You know, or it could be these 2 or these 2, right? And we check to see if we hit the boxes. If we're a leaf node, sorry, we hit it. If we're a leaf node, we look at the spheres. Now, after all of that code, we basically know if we've hit the boxes or not, and if we need to traverse down the tree. But we've got this sort of branch here. We say we hit the left, and then else if we hit the right. And this one's saying if we hit the left and we hit the right, and yeah. Wait, has this got a bug? Yeah, this might have a bit of a bug in it, I think. It might go down an extra layer. Huh. Yeah, I think it's got a bit of a bug in it, but anyway, we can fix all that. So, effectively, I think we can get this down to one if statement. Like there's these sets here to the same variable in every branch. You can pull those out and pre-calculate it somehow. Maybe you can get it down to 2. Because when a GPU is going to execute this, chances are like it's like if all threads take the same branch, it's absolutely okay. You know, you might get a few extra VGPRs which are reserved with branchy code, but if they all go down the same branch, it's typically okay. But when you've got many branches like this, they're not all going to go down the same branch. Ones next to each other the pixels are next to each other, quite possibly actually. But yeah, around the edges it might be quite bad. So like if you have, as soon as you have different threads going on different branches, essentially this whole code block will just be executed with where some threads will just do nothing, right? And we want to minimize that. It's kind of, yeah, basically. So what we can do is so this is hit. So think about it. So we basically select to go down the left or the right. We take a sort of, if both of them hit, we take a preferred route, by meaning the one which is closest, which is a pretty good optimization. Actually got us a good win. So I think we tried this before, right? We can move the preferred out. Hey, not so red, how's it going? Welcome to see you. Yeah, not doing bad, not too bad, thank you. Yeah, it's been, busy, busy, busy. But just been thinking about ways that we could improve this ray tracing, basically. So we've got like 4 different things we're gonna explore today, so it's gonna be pretty good, hopefully. Um, but yeah, just yeah, it's been busy. Looking forward to my time off, which should be in less than 2 weeks now. How about you? How's things going? Is there a way to do a ball is occupied type of thing to avoid that? Is occupied. I'm not sure what you mean by is occupied to avoid the going down different branches. Um, yeah. Yeah, is it faster? No, no, not faster yet. We're still 7 times slower. Um, I'm not sure we'll ever be as fast as it, but I'm hoping to get as close as possible. We might, in a very hacky way, get past it with prediction. We'll basically predict the hit from the last and use the one from the last frame. We might reproject it as well. With that one, we could potentially, I'm not sure about the numbers, but it could cut out traversing a whole load. But the problem with that solution is if the whole scene changes, is actually going to get spiky performance. So I want to make sure we can kind of guarantee that spike won't come at any time, because you can actually make some code which runs really fast, but as soon as you do something different, it just you all of a sudden hit like 30 FPS or whatever. We kind of want to avoid that, or we're going to want to minimize the amount of solutions that kind of can do that. But yeah, so I'm hoping to get it faster. If we can't get ray tracing as to be fast enough, we might have to go over to. We might have to explore a different method for basically rasterizing spheres. But we'll see. We might have to have one for a far away renderer and a close up renderer or something like that. But that will be. I want to avoid that because otherwise I have to kind of implement stuff twice and things like that. But we'll see. You have a cool method for rasterizing spheres. Awesome. Can you do a projected sphere with your core method? Like a projected correct one. Like I know you can do. Is it with the atomic min method where you basically wait? No, no. Yeah. Are you referring to compute only? Because that's that's our restriction. Good. Thank you. Work remotely today, so I have some time to rest. Sweet, sweet. That's good. Yeah. Awesome. Um. So I think what we can do. So basically, if we hit both, we want to do this branch. The rest of them could just be worked out, right? That's the idea. So like first of all, we've got an array of Boolean, right? An array of Boolean is kind of dumb, right? You know what is an array of Boolean? EU32. It's an array of 32 Booleans. So, jobs are good. And so this way, like basically a ball type is kind of silly. Right, so put brackets around these because you never know the operator precedence with C, right? Basically, ray tracing a single object for each fragment in a triangle hole. Triangular hole. Right. So basically you're using triangles. So you triangulate the sphere and then you ray trace against it. Right, okay, I got you. Yeah. Yeah, with minimal vertices, right, yeah. Yeah, kind of the commute time is definitely good. Um, gives you time to replace it with something healthy, like exercising or working out. Because when you travel to work, you sitting down, and then you get to work, you're sitting down. Come home, you know, get your dinner, go to bed. Um, not very healthy, is it? So a really great thing is having some time to work out. Basically, that's why I like working from home. Get some workout time. Yeah, so that's another method we could do, I guess, is ray trace per object. Um, there's a method that people do with compute, um, where you use the atomic min and on a text on a pixel, right? You're rendering to, and you put the depth. You put 24 bits of the depth in the high bits, and you got 8 bits to do what you want with, right? You're meant to use a U64, but if you don't have a U64 support, then you got to use U32s. So you can kind of like rasterize that way, um, with compute only. We have this restriction with compute only because we don't want to do the whole traditional rasterization method. Hey Morgan, hey. Shema Vimarsi, not really. It's a bit messy. It doesn't really make like if you got anything that you see where it's like, wow, that's cool. Like, I'll just send over in a snippet. How Hammerland textures in a model built out of spheres. How could you get their texture coordinates? Um, so, um, yeah, so I'm not sure if we'll actually texture spheres. Yeah, I'm not sure how we're going to do it, but they might just be a solid color, with lighting, obviously. We've got to see what the style's going to be. But yeah, texturing could definitely give them more. But yeah, I'm not sure how we'll get the UV coordinates. Um, there are ways to solve that problem. Um, you could basically transform it back into local space of the model, and then maybe have them assigned in local space of the model or something, and you know somehow we'll get that data that way. But there might be a more elegant way to do it. I'm not sure. I haven't really thought about that problem. Really. Um, Procedural textures, yeah. Yeah, procedural textures, that's the way to go as well. That's probably the way we would gear towards rather than mapping it to UV. Yeah, we'll see. That's kind of a space I've not already explored, but I've sort of seen a lot of material on it around. Um, oh yeah, the decals basically. You project the decals onto the. Yeah, that's another way to do it with decals. Um, if you want to get literally a texture on it, that's another way. I like to see that because I intend to do that for my stuff. Sweet. Yeah. Procedural textures are kind of nice. Because you can just like apply it to an object as opposed to you know, UV mapping, which is like horrible. Maybe you can like paint a material on a, you know, procedural textured material onto an object, right? Which would be pretty cool. See, I've got this is hit bit set. Basically, the way, let's just rewrite this. Let's just move it like this. So we only really want to go into here, providing that both of them, like, is hit bit set equal to 3, right? That means they're both hit. So I could just say, okay, maybe it's better. Now there's this and in here, right? This doesn't look good either, but because that's basically another branch, right? But we already do this earlier in the loop above, right? We already check if there is a child by checking if we want to do any of these spheres here, right? So get ready for it. There's another bit set, but we could just chuck them in the higher bits, right? So you just go Boolean has child. So stick in a little VGPR or whatever, and then we'll cram into this VGPR or whatever. So has child, and you want to shift it right by that times 2. Wait. Plus 2. Yeah. So they're in the higher, right? So, you know, I've crammed into one thing. We should probably stick a comment. We're like 0, bit 0 is the sort of left child, bit 1 right child, bit 2 left child has children, bit 3 right child has children, right? So it's all there, easy to understand, right? Less stuff to decode. And then here we only want to, you know, here we are, you know, if we've hit both and they both have children to go down to, right? So that is basically that, right? That'd be pretty cool, right? So there's one if statement. Can we keep it as one if statement, right? So the next thing to do is, the only other thing we did is basically set this guy to whatever the preferred, basically the preferred child was, right? So you've got this preferred thing here. Plus preferred. There we go. So the next set of nodes we want to look at is the preferred, the child of the preferred node to go down, right? So it's the closest one. So that would be cool if we can get it down to this, right? It's one branch. And, you know, it's less of all of this, right? But, like, and the compiler can have optimized that. Like, we know it can have optimized that. Because it involved doing stuff up in another loop. A lot more complicated. They made, you know, basically making this guy. So what's the other thing we could do? So this, the problem is these are not always set, and we tried to. Well, it is always set. What's the way to do it? Yeah, that's definitely true. What we're comparing against right now is one sample. You know, this is one sample of comparison, a very basic scene. That is for sure. In a more complex scene, the tile binning is not going to be able to stand up to the BVH binning in terms of actually, so the BVH traversal. In terms of actually being able to cope and render, because we've only got, the tile binning only has a limited fixed size per tile. So we'll see how much, like, we can definitely add more objects to it. But yeah, I think we can add more objects, but we've got to keep the number of spheres kind of down, I think, for now. So that's definitely true. I think we've got 256 per tile. So yeah. Right. So we've got this problem where preferred isn't really going to be like, so these T mins aren't going to be set. Sorry, they are going to be set, isn't it? Yeah, they're going to get set. But if it's hit, like, we kind of want to say if it's not hit, we kind of want to say if it's not hit, then make it infinity or something like that. But then that would involve an else statement, but maybe it's fine. Maybe we can make it a select. I'm not sure how good this is. We might have to have a bit of a play. This will make it like a select instruction where it's sort of like, it's a conditional move. But I'm not sure how good that will be. So yeah, we'll say infinity if not, right? Yeah. So this feels like it's we've made it better, right? We've brought all of this branchy code down to this. We're missing one thing. This else statement. No, I think it will be fine. That needs to go, actually. Because you will go down the left anyway, then you'll be past the end. Yep. Okay, that's it. That should be all we need. Which would be pretty cool. This one is if we go off the end. Yeah, maybe we can make this better, but I don't really know too much. Let's just run it and see what happens. Maybe we should double check. Right, so this is hit bit set. We set it, we only set it if we hit, right? Then this has child is kind of wrong, right? Oh no, that's right. No, that's wrong. This meant to say is leaf. So if it's not leaf, then we're going to add, we're going to shift it to the next 2 bits instead. Sweet. Nothing else changed, right? So then down here to traverse down, we get the preferred one to go down. Right, what is up with this? They're saying if the left is greater than the right. Surely this is the wrong way around. Oh, no, it's alright, isn't it? Yeah, so the left is further away than the right. Then we want to go down the right. This would be 1, right? Okay. So this is saying if both children are hit and they have children of their own, right? And then we basically store one of them. We store it in an array to come back to later. And then we go down to the next one. It's fine. Cool. Maybe there's ways to reduce this, but let's just hold off for a minute. Alright, so we basically had around... Okay, 0.72 it was. This is because I moved it elsewhere. Or I did something with the debug settings or something. So 0.72 is basically to beat. So let's see how we go. If the stream dies, I'll be back. You know the drill. Right, we're still here. That's actually made it slower. Horrendous. Damn it. Way slower. All those speed improvements we got are gone. Why is that? I have a feeling it's this line here. If I move this in here... maybe not. Yeah, it's this line here maybe. No? You know what, let's put this back here like this. Let's move that in there. And let's put an else on here. That made it way slower for some reason. We literally have less code now down there. Right, something fishy is going on. It's as if we're traversing more nodes, right? How can it be that much slower? So if we open up the shared, let's enable this heat map, right? The number of BVH tests. So let's undo what we've done. I should have probably git stashed it for safety, but you know. Right, let's give that a go again. Yeah, 0.72 there, see? Right, screen grab this and so we can compare it. Because I'm not going to remember that. Right. Definitely bluer on the outside, isn't it? So it looks like it's more red here. So as I expected, right, there's extra traversals going on. So something is fishy. So I think we're hitting max iterations here. Yeah, it is. It's red overall. So I think we're hitting max iterations here, which is like 256 or something. No. No. Right. So what did the code used to look like again? So we did it sort of. Right. So the problem is if you don't hit any of them, yeah, this is the problem. If you miss both of them, right, it's going to carry on down the children. That's the problem, right? So, we've got to solve for that problem now. So the problem is yeah. So we could introduce it here. We say, oh, if that one is equal to that, or hit bit set equals 0, right? That's the way around it. But we'll see how much this helps, right? But it still kind of adds another branch technically, right? You know, it still adds more branches. I'm not sure which way you can look at it really. That's probably better. Right, technically we are probably back, but we're a little bit keeps ping-ponging between faster and slower again. Yeah, but it's not. Yeah, we are back, but yeah, it's not as fast though. Maybe this is a problem. So you can try and bring back that select again, I think. So let's do that. It's back. Right, that's more steady. 0.75 now. Definitely more steady. The other one was pinging up to 8.4 for some reason. Right, that's just sitting there, steady. Yeah. But it's... Also, this is not a good test because we've enabled the debugging code. So let's turn the heat map off. It's actually slower. Damn it. Actually slower. No. So I'm not sure if it's this here that's making it slower. Like this could be, but I don't think it is, right? Where we're putting these two bits into this bit set. I don't, it's doing some shifting. Um, right, it's doing some shifting and stuff. Um, hmm. Yeah, I'm not sure. Let's have a bit more play. This could also be another one. Um, like, so another way of doing it could be. Hmm. So you've hit. Let's see if you haven't hit anything. Um, like technically, yeah, this needs to come after because of this guy, right? You don't know if you've hit a child until you've updated it. But you know if there is children from this bit set, right? Because it's in that bit set now. So technically, this can actually go, but then you have to execute both branches. Maybe. Yeah, so maybe you can actually say, um, wait, so all you need to do is say if that's equal to 0, right? Because you haven't hit anything and there's no children. Sorry, wait a minute. Um, yeah, you just want to check you want to and out the hit bits. Because you don't really care about those. You just want to care if you can traverse down any further. So if you just do C, right, that'll get you the two top bits in a nibble. If has traverse to, yeah, that one. So then you can kind of stick this in an else, right? Yeah, interesting. Which one are you more likely to go towards anyway? I don't know. I'm not sure how much better this would actually be, but we'll see. Because it's a bigger block of code now on each side. But maybe it's always going to be that case anyway. So you preferred if it's all the bits on. Right, seems legit. Let's try that. Right, so we got a bit faster from where we were, but it's still not faster than our original one today. Yeah. Is it either one or the other? No, you're still going on both. Depending on the, because your pixels just being different. Yeah, traversing different. Um, yeah, I have a feeling that it could just be. I have a feeling this could be the bit of the slowdown. Is having to set this to infinity. Wait, but we haven't. We might not have to set this to infinity anymore. Thinking about it. Because we've moved it inside this branch. Oh no, you will have to. So I think what we might do is you want to find the least set bit index or something like this. Oh shoot. No, wait. If it has two children to traverse to, if it is hit. If we hit the left and the right. Yeah, I think we're missing something here. We want to handle the case if we didn't hit anything. We got rid of those two bits now. Yeah, I think that's fine. Yeah, that's fine. That'll work. Okay, so preferred. Um. Hmm. Yeah, I think we can just set it to. I think we can just set this to. We'll set it up in here. I'm not sure if this is actually any better. So bit LSB, you get the least significant bit that's set, right, and the index for that. And go down that one. So if the left one's set, go there. If the right one's set, go there, basically. So this will allow us to remove this check here and possibly make, this could be the thing that introduced the performance issue. I don't know. So now T-mins are only both set when they are both, sorry, they're only used when they're both hit. So that's better. Possibly. We'll see. So we'll come into here when there's nothing to traverse down, or okay. There might be a way to make this so improve this, but let's see. Right, so that's made it a bit better. Like it's going down to about 7.8. It pops up into the 8.0, but it's still actually slower than what we had when we started with. So I'm not sure why that is. Are we traversing down? You know, we should compare the colors again, I reckon. So let's get the colors back out. Right. And let's see sort of like, have we just made it traverse down more nodes by making this change? Right, let's give that screen grab. Cool. Okay. I just overwrote my other one, damn it. I can't have two open at the same time. Dude. Right, I'll do that one again then. Yeah, I'm kind of confused on why this isn't... Why this isn't quicker. Like, what have we done worse by this, basically? Right, so let's get proper screen grab. See, 0.72, way better than what we've been doing. Super confused. Let's open this up in like Krita or something. Then we can like switch between it. Or paste over it or something, right? And we'll clearly be able to see a color change because it'll be the exact same rectangle. Right. Are you open up in Korea? Good, there you are. Let's take another rectangular. Right, so copied it. Literally no difference. Right, so something in... I'm pasting it on top and I'm not seeing any difference in color. So it means we're traversing down the same number of nodes, but what we're traversing over is... Wait a minute. Oh, right, it's saying 7.2 because I've got the debugging heat map on, right? Surely. Yeah, okay, it's gone worse again. Okay, that's fine. Good to know. Right, so something with our code is still a bit... It could be these guys, right? The way it's having to pack, like, it's doing more arithmetic now, right? There's more instructions that it has to execute to sort of pack it into this bit set. But we do save when we do these tests, right, in a way. You know, rather than being 4 variables, it's just 1. But that could be part of the issue. So is there a way that we could maybe fix that? Like we're packing it. There's 2 bits. You know, instead we can pack the bits together differently and maybe Maybe get it as one op or something like that, or a few less operations or something like that. So there's the sort of is leaf. Yeah, I'm not sure there's much else we can do there to make that better. Basically. We could probably reduce this a bit. I assume the... See, that code that we had before must have had some optimizations ran on it, which just made it better. In a different way. So stack is equals 0, right? Why would you hit one that goes out of bounds? Right? That's the question. Oh yeah, because if you hit it, you go down the left child. Yeah, this says if you have children of their own. Yes, you'd never store that in there. So this can go. Less code. Right, see how that turns out. Right, so let's brought it down to 7.1 with that mode on. But it's still not quicker than what we had, and it looked even worse in terms of branching. But we made it sort of less branchy, and it's kind of... or maybe... Hmm... Yeah... So we only need to store in here if it's not a leaf. Okay. Yes, we go in here if it's a hit, and we go in here if it's is a leaf, which is a shame because we want the opposites, right? We want is hit and is not leaf. Yeah, maybe there's ways to do something different, but maybe not. Hmm. Right, let's look at the diff a bit. Yes, this is the code we used to have, right? So we've just changed. So we're two booleans instead of a bit set. So there's that extra packing, which could be what's making it slower. But we've removed this sort of weird branchy thing, right? Look how branchy that is, right? And we've replaced it with basically like, okay, it's got an operation there maybe. You know, but we've condensed it down to this. So it's a bit confusing. And why this was better. So I guess the way we could see is we bring back the old code, but we use it with the new bit set method, right? And then if that ends up being just as good, like if this improves it, then it was something to do with this branching method being better, right? But if it isn't better, then it's something to do with the bit set that we've added, which is the problem, right? That's the way that we can tell. So if we bring this back, joys. So let's comment this out. And let's bring back this code. Let's get rid of these git minus things. And this was the old code, but we also had this thing, right? Where we sort of like also had another if statement in there. But this if statement, it was here. It's going to be really ugly code now, but that's fine. So we've got that if statement there. So the problem was this is hit is now sort of is hit bit set and 1 and 2. Right, so that's the right hand side. And if the right has okay t-mins, they'll both be in there now. That's good. Yeah, I think that'll still work the same. Right, so that's actually slower, right? So what we can guarantee then is the problem is actually the bit set that we've added, right? Because we did all this extra packing for some reason, right? Like doing this, I don't know if it's doing this per se. Like, so the only thing that's different from the old code is we've removed one if statement, which is not going to make it slower, right? That if statement was never fired. But then, wait, let's just double check that. Where's the bugger? It's right here, isn't it? Oh. Yeah, it was that check, wasn't it? It was this check in here when it's running. Okay, that actually brought the speed down a bit. So it must be fired. Oh no, sorry, I was looking at the wrong number. Right, it's 83, it's the same one. Yeah, so what we can guarantee from this then is this is bit set thing, is hit bit set that we've added is actually the cause of making it even slower now. Even though we had all this branchy code, right? But what we can guarantee then is if we remove this and bring this code back in, what we can see is that was 8 2 or whatever, right? And this is 7, 9. Right, so theoretically, if we can get the same, if we can merge those two solutions together, we should be able to scrub some speed off there overall. But we'll see. It should be down to 6, 8 maybe. I had to fault my repo into my work account because apparently working on multiple accounts in Git is rocket science. Your own repo is apparently... What? Huh. So is there like a bit of code you wanted to sort of like basically copy over, or was it like... Or are you working on one of your projects at work time as well? Like what's the... But yeah, no, I think you can do it in Git per repo, isn't it? But there's also a global flag, isn't there? Something like that. Right, so I thought this bit set would have been better, but apparently doing bit sets and shaders ain't good. Ain't good. So, what about 4 booleans? Is that really better? Like 4 booleans? You gotta be kidding me that 4 booleans is better. This would just be equal true. And then this one would be this plus 2 equals not leaf, right? Like, weird if that's... This is better, right? So, so this one you only care if 3 and... This one you only care if is hit 3 so and not so if not 3 and 4 we don't have any children to traverse. Where's the other bit set thing? Right, so preferred is basically if the left one, if the right one is hit, go to the right. If left and right are hit, something like that. And this one, if all of them are on, that isn't really that great. Wait, or do you know it already? It's if the left or... Wait a minute, you kind of know if the left and right are hit simply by knowing if the child can be traversed down itself. So maybe you don't even need to know if the left and right are actually hit. That's interesting. Maybe you just need to know if left and right are hit. From my personal account into my work account. That's what I'm using right now. Oh, right. I see. Yeah, I guess you would basically have 2 different folders for the same repo, right? And then you basically set it locally. But yeah, Git is complete rocket science overall, right? Like half the commands that you type don't really, like, are really difficult to understand at first. Yeah. It's kind of interesting how we all landed on Git, though. This is a bit weird. And they have children of their own, right? Okay. Fair enough. Oh, you might need it for this though. But yeah, anyway, let's just see if that ends up doing anything better. It's gonna set them all to false though. Right, now nothing's rendering. Way quicker, woohoo. Sure. So if the left and right doesn't have any children. Yeah. It might be this preferred thing that could be wrong. So it's preferred to go to the right when the right is hit. Hmm. Oh, what could be the bug? If the left and right have children and they're both hit, go into here. Hmm. I can't see the bug anywhere. What's going on? Why is this? Right, let's just see if it's a compiler bug. I don't think that's right. Okay. That's what I thought. Is hit is true. Is leaf. Set it is not leaf. +2 of that, yep. Right, seems pretty legit. What is the problem? So we're not traversing down all of them for some, or coming back up maybe? Yep, that makes sense. Hmm. Ah. Yeah. You want to go with the one that doesn't have any... Oh, that says 4. That's not right, is it? Whoopsie. Like I've been programming in Lua or something. No, that's not right. So, but this one also had a bit of a problem. This should be the right... Yeah, I think we only need 2 booleans still. We only need 2 booleans. Is hit and has children. This is all we need. Yeah, that's all we need. So this line won't be needed, and this +2 won't be needed, which is a big help. Okay. So I think then is hit and has children. 0 and 1, because apparently it's better if it's not a bit set. Fair enough. And then preferred would be if the right one. So we want to be 1 if there is a right node that's been hit and has children. And then we're going to here if both of them have been hit and has children. And then we store the least preferred one, and then we go to the most preferred in the next traversal. Okay, that should be what we're looking for. Okay. Right, I think we're a bit... We've basically hit the same point as where it was at, right? It could be a little bit better, but it's not by... It's very negligible if anything. Right, it might be... Yeah. There's an extra set here now. Yeah, I think we also had this outside of here, and for some reason when I played around for that in the past, it ended up being quicker, and I don't know why. No, that went slower. Alright. Okay, let's do a git diff quick. Yeah, we did 0 them, that's good. Okay. So the only thing that's different now is we've moved this one inside here. This is leaf, set that there. We've reduced all this branching now and simplified the code. Right, so maybe we can change this a little bit more. Oh, just want to investigate this a little bit more and we'll move on to something else. So can we simplify this even more? So yeah, this sort of is preferred thing. Yeah, I'm not sure there's much else we can do, to be fair. This part of it. Right, what about this one? Well, I've got an extra if statement in here. But it's only one if statement, right? Yeah, this will probably just get optimized out anyway. We're probably not going to have this ever, so might as well remove it. Have you looked into generating speed? Have you looked into the generate spivvy, see if there's anything that looks off? That's true. That's another way I could do it. Yeah. Very true. Yeah, it would be quite difficult to debug, though. Yeah. Like, I don't have a good way of viewing it where I get like a line of code with the SPIV next to it, so it will take a little bit to decode it, basically. But yeah, that's probably a good approach to go for later. So we don't need this to be a loop anymore, we just have to go back. And if not, we've reached the end. I think the compiler should have done that anyway, right? But we put it in a loop because maybe we wanted to skip one if it was, you know, we had a team in there or something like that, so we could skip it if we've already found a hit that's closer. Right, for some reason, that's got basically like not going down to 7-1 again, which it was, even though bloody bizarre. Like this was better apparently. With the while loop. Probably the else statement. Well, you're going to set is running to false anyway, so whatever you set this to probably doesn't matter, right, in the long run. Because we're doing this min on it anyway. It will underflow. Bit of a hack, but we'll see. Yeah, that's decided to keep going for some reason. Whoops. Yeah, definitely very negligible. Let's just put it back. Okay. Right, let's just leave it at that. I don't think we made any improvement there with the speed, but it's made it less code at least. Bit weird though. You would expect it to be better. But maybe we've just done as good as the optimizer did. I'm not sure. In that case. Okay, so the next thing to move on to was this one here, which is predict the closest hit so we're going to remember the previous hit from the last frame and basically test against it this frame, and then set this closest hit depth. And this closest hit depth is something that we use to basically skip doing any tests, right? When we test against an axis line bounding box, we say if it's less than the closest hit depth, then you're allowed to go through and traverse more. So if we have a way to preset this variable, right, then theoretically we should be able to get really good speed improvements for scenes which are basically still. But as soon as you start moving, this starts to become problems. But what's really great is we can color the view where we can see the mispredicts, which would be very useful to debug and see kind of how much we're mispredicting. And if we mispredict a hell load, then it's not good, right? Because then you get very spiky performance. Right, so before we do that, I need to go back and get a drink quick, but should be pretty easy to make this one. We just need a new texture, and that's about it really. It's pretty simple, and some testing code when you start the shader. Right, I'll be back in a couple. Right, welcome back everybody. How's it going? So, yeah, we want to see if we can predict where we've hit, right? Or where we're going to hit. So let's go ahead and make a new texture that we're going to store in. We just need a U32, right? Could you use some of the pyramid scheme for the closest hits, tracing a downsampled image first? Interesting. Right, so what you're saying is trace a very low res. Yeah, so that will only be good for, you know, when we do this, it'll be less good, right? But it might be fine, actually. Might be okay. Yeah, so what you're saying is trace against a very low res. Or not a very low res, maybe half res or something like that. So that's like four times less threads, right? Going. But then if you did a quarter res, then that's, 8 times less threads going. That's interesting. Skip every other row and column. That's not bad, because the way that I was thinking of doing it is using last frame and doing a reprojection, right? If you did a reproject, then that's a full screen operation, which is not the best thing to do all of the time. And the problem with a reproject is it doesn't handle stuff entering and leaving the edges of the screen, right? So, yeah. What GPU do I have? I have an RX 6600. So a full screen operation isn't that bad actually. It's about 0.04 ms for a clear screen. But on Intel hardware, it's like nearly one ms, right? I've got like an old laptop that I want to try this thing on. Not sure I ever want to support it yet, but it'd be cool if I could. Yeah, so doing a low resolution render, see, that's not a bad idea. Because I just need to know the object that I hit, right? Hmm. So I can test against it again for that pixel properly, and then set the low closest hit in the traversal. You know what? We can give it a go. Ain't that bad. Or render line by line and use the previous line as the prediction. Yeah, I think that will have some threading. Plus, you want to render in quads in 2D anyway, rather than 1D. That ain't a bad idea. I like it. I'm gonna go with that approach. Nah, we're not tracing triangles. This is a triangle-free engine. No triangles. But yeah, I think we should just give that one a go. So we need a low-res texture then. Do you trace against it? Find the closest hit, store it out. Yeah, spherical graphics. Yes, the only problem with the low res solution is our spheres must have to be, right? So let's turn off this BVH thing. Let's just think about it for a minute before I go ahead and write any code. So the limitation is our spheres must not be Do you plan to have huge level of detail of spheres? By that, I think you mean like number of, yeah, like very like tons and tons of spheres, basically. Maybe I'm not sure yet. That's the thing, right? So I just wanna leave the door open for that, right? Or I at least want to know where the edge cases of a particular optimization that we're going to make as well, right? Yeah, potentially we do want tiny spheres. I'm not sure yet. We might want them slightly bigger. So even this, when they're this size on the screen, right? And this is some weird resolution, right? This isn't right, but they're about this small. So you can still make them out as spheres. Even with this, if you were to do quarter resolution, what you see is, so there's a 4x4, right? You've got a bit of leeway. You will have mispredict though. With your neighboring guy, we'll have a mispredict. We'll have half of them that will mispredict, basically. Where is it? Yeah, those are mispredict. These won't mispredict. Yeah, it's not bad idea. But this only has to be a cheap operation as well. We don't need to do full rendering, right? Yeah. We just have to know. So maybe we'll get away with a half res in other situations. I'm not sure. So we don't need all this testing code, right? How does the performance look when the sphere's in the exact same position? I don't know. It doesn't really get any better past a certain point. I think performance, we'll see. It does go down, it goes down, it goes down. These spheres now look horrible. Because I've got the anti-aliasing set up properly with this lighting. But yeah, they sort of just, it stays about at 0.2. Right, these pixels will just take forever to go, basically. Yeah, we don't want them this small, right? This is where we'll do some different, we'll have some different thing going on. So I think, though, if we do quarter res, we're going to have a new method, which is this LOD, right? So we're going to be basically, we're probably going to be fine. We just have to make sure our LOD is like 4 pixels big or something, maybe. I'm not sure what it'll be. Yeah, we'll think about that. Yeah, this can work. So let's copy paste the shader. So the thing is, we're doing a pre-pass. So all the limitations by doing this pre-pass at quarter res. So this is only obviously for primary rays. If we did any bouncing, basically, it won't be good for that. There's definitely an optimization for the primary rays only. Something to take away from that. So we can call this like prediction pass. I don't know, prediction, something like that. So you have the same sort of thing set up. You'll still go over everything, but you literally just need to know if you've hit a sphere, right? So all of this can just go. All of this can just go. This is the anti-aliasing stuff, which is kind of disabled at the moment. We still need this traversal part here. We can get rid of this heat map stuff. Doesn't really matter. And we'll just render out. We don't need a color. Right, what we're going to be doing is rendering a closest hit for this pixel. Right, so we're just going to put a float out. So the texture. So we don't need color. We don't really need a normal either. So the optimizer will probably get rid of all that code anyway because it'd be inlined. Prediction. So what we're looking at doing is storing out closest hit depth only, right? So let's get these in here. Yeah, but if all spheres have the same position, there could just be one BVH node, right? Or the worst case, right, if they have the same position, right. Okay, understand the question. Or worst case, all of you, same bounding box, got it. So the plan is, when we make these models, right, these sphere models, technically, they're going to be on a grid. So we'll literally just have a grid of spheres, right? So there'll be a sphere in each one of those grid cells, and that goes in 3 dimensions, right? Now, but when they're in the game, they will sort of react. They'll probably react in some way with movement. They might move around a bit. But overall, they're gonna their sort of default position is that grid, right? And they might be animated as well with bones and stuff, right? So you will get gaps between the spheres and stuff. I've got to play around with the sphere sizes. You know, they might be bigger than a grid cell, right? So technically they overlap a bit, right? But yeah, so effectively we won't have spheres that go on top of spheres unless a model goes on the same model. So we've got to stop 2 models going over each other, basically. But they can probably go behind each other, and you just but we should be able to skip the one behind it the way the traversal code happens. The way the traversal code works is it will go for the closest hit first. So if you have a model behind another model, you have a model inside of a box behind another model, and the camera's here, right? Or the eye, or whatever you want to say. It'll test, these are in a tree, right? It will test both of the boxes, and it will only go down this box first. And then when it comes out, it's got some closest hit somewhere, and then it will not go down this box and skip it. So we have those optimizations in place. Yeah. So hopefully we don't have that problem, basically. Prediction. Sphere voxels basically, kinda, but they're not limited on the grid like a voxel is, right? Output is an F32. Spheres input. Don't think I need any of this stuff. Right. So let's just double check if there's anything we could just nuke. There's probably a lot of things we could just get rid of here. Yeah, there's a color. And the normal. Let's get rid of these at least. Oh, and the near miss stuff. Crap. I'll make sure I'm in the right shader. I could just be killing the other shader. Damn it. What am I doing? Too many so much of the same code. Right, still in the prediction. Right. Good. Ought to be good enough. So, we've got this new prediction shader, so we need a new texture. We'll make it quarter res. Bearing in mind, I don't think I've got any form of yeah. We'll just do it. We might have to allocate it as a 4K texture. Because we've tending got screen resizing. Let's just do it 4K. So we save to. We don't have like temporary allocation yet. Alright, so we'll call this one quarter res. Quarter res. Okay, so sphere closest hit quarter res. Res ID. Terrible name. Quarter res texture ID. There we go. Texture 2D floating point. I didn't have a floating point. Yeah, what do we want to store it on the inside? Probably just we'll just do a full floating point. But we could probably pack it down to fixed point. U16 or something. But yeah, let's just do float for now. My telescope is buggered up. Am I going to do grid? Does movement snap to a grid or you're not sure yet? Got it. No. No. It's just when you edit. It's just when when we make the models, it's just going to be snapped to a grid, right? But in the world, it would just be free. It would just be like a triangular mesh in a way where you can just animate it and right. But it's just made of spheres instead. Are you doing a grid-based physics? I don't know what physics will do. It totally depends on the game, right? Whatever's easiest to do for the problem that we have. Because I'm the only person working on this game, so I've got to like cut corners in places. But it would be good to do my own physics, right? Who wants to use a physics engine? Quite a lot of people do actually, but I wouldn't. I can't believe people don't like having fun, you know? There's so much fun in making stuff. Let's float. Right, I've got a float. So we have got ourselves a float. Because apparently there's unsigned floats and textures. There's no view. Like, this is kind of like OpenGL, where you've got the internal format and the view format. We've got that sort of system now because of the way our compiler works. It's pretty cool, actually. It means when we have stuff as storage textures, that's the actual format it is. Right, so we've got this boy now. We'll actually make it a quarter of the wait, temp display width? What are you doing to me? That means you can't resize it when you go out of bounds. Damn it. Alright, we'll do divide round up. Yeah, we're not going to be able to resize the screen. I think that's fine. Yeah, it's all fixed anyway. Just divide by 4. Yeah, we won't get any out of bounds. So we actually have screen resizing in the engine, but in the renderer, we've just hard-coded everything. That's what's going on. For now. And it's some weird resolution, like, yeah, but anyway. No, that would be fine. So this is our output. We want to basically copy this ray tracer, and we want to use the new prediction one. This is the prediction. I know I could probably call it the predictor, but there we go. Our output one is actually going to be ggfx.spheres closest hit quarter res texture ID. So that will be put into there, and then we synchronize on it. We're writing to it, right? So the output dims, though, is that lovely core divide round up. Please round up. And then we still need the spheres and the BVH and all that stuff. We've got to maintain 2 traversal code now, but you know, it's the way it goes. So when we're launching this guy, it's the output dims .x 8x4 wave size and all that jazz. This has got to be adjusted to the prediction thing. Right, so that should run. We can't actually see this because it's not rendering to a screen, but we can run it in render doc and capture and have a look. And we'll just see it. Yeah, and also it renders a closest hit distance. So it's basically a depth buffer, right? So there's that. Ooh. We need to initialize it. Okay, this is another one, little bugger as well. Yeah, so the other problem is then our shaders, we actually need to write out regardless, right? We need to write out the infinity. Because otherwise you're just going to have empty pixels. So that won't be good. Right. So we've done a whole new shader, so chances are the stream could crash. But if it does crash, I'll be right back. Hopefully not. Right, let's go. Validation error was saved for the CPU crash. Takes a while because it does an address to line on a Vulkan validation layer and does the stack trace. So the Vulkan validation layers shared library, and it does it like 700 times, and it's like 500 meg or whatever it. Horrendous. Anyway, we're here. Okay, so I've actually put MIP levels on it. Whoops. So we'll fix that. I copied and pasted it from the occlusion texture, which we don't use anymore, by the way. So that should just be one MIP. All right, we're running. So that's actually 0.09 ms to do that quarter res. And obviously, as it gets less complex, actually it's about the same. That's interesting. But yeah, 0.09 ms. So it's about 0.1 ms. So we're automatically adding that on by doing this. Should we see what it looks like in RenderDoc, yeah? So the thing is, compared to the solution that I proposed earlier, yeah, the solution I proposed earlier could have been cheaper, but it would have been more, it would have been incorrect more, right? So what's great is it does it on the same frame. Okay, so what have we got to do now? There's a key render doc. That's it. Let's launch that guy. I really just get it installed on my system proper. Right, let's just capture the first frame. We can view the texture. Here it is. The pass is probably that one. Right, so it's just this red texture. Super nice. So we just want to, probably put it, 69 is probably good number. No, maybe not. What about 128? All right, we're seeing stuff now. So basically, you got this like, right, 169. There we go. So it's quarter resolution. We're storing. Wait, we shouldn't be storing the depth, isn't it? No. Right, what do we want to do? So we can either put the depth in there. You won't know if you've mispredicted though. Yeah, we shouldn't be storing the depth. What we need to be storing is the we need to be storing the sphere to test against. Then in the shader we test against that sphere, then populate it with that depth. That's what we do. So it's not close. Sphere closest to quarter res. Yeah, so we'll actually change it to a integer and store a sphere index in there instead. Sphere index. And we'll do U32 max, right? Okay, so in our texture, that's a U32 now. Boom. Right, so that should still run. Cool. They're still obviously the same. Not much has changed. So now we just need to bring this guy in to our regular thing. So this one is going to be our sphere closest hit prediction. Res ID, something like that. So we need to put that in. which means we also need to synchronize on it. So we're reading this time. So now that's all set up. Now the thing we need to do in the actual shader is simply do an early test on it, right? So we want to do this, and then the only thing we want to do is pre-populate the hit depth, right? So you just go, it's very simple. So you just say, okay, you get your sphere index, and you read that from BC sphere closest hit prediction res ID. Cool. You do your sort of like load texture 2D. Yeah, I forget what this is, to be honest. Yeah, 2D, right, fine, got it. 2D U32. So we're loading from that. It's 2D index, so it's U32 times 2 of, so it's just U chord divided by 4. Right, no round up. All right. Yeah, I'm not sure why we needed a round. I don't know. Divide U32 times 2, 4. Divide S, because it's scalar on the end. Right, so that will sample our pixel. So it's the lower left pixel of that group of 4 that you're going to reuse. So there's your sphere. Now you simply do your Rayverse Ray 3D versus sphere. So you need to actually get the sphere. And we'll do a lovely bounce check as well, because I don't want the GPU to crash and burn and destroy the stream. So this Ray min, Ray max is all set up, I think. If we hit compile, does it? No. What's the problem there? Oh, that's a read-write texture. I'll read it. Sorry, write only. Thank you, compiler. So yeah, we get it here. We have predicted right. So we say hit success. Then this means that we can actually set closest hit depth, right? Pretty interesting. And all of its buddies to whatever this is, right? So that's pretty cool. And this, but what we might have to do is actually take away some form of epsilon, which we'll play about with, because we don't want it to go down the tree and ultimately find the same sphere and test against the same sphere again, right? So we want to kind of avoid that. So we'll see how it ends up playing out. So the performance we're looking at is obviously 0.72, this lovely number, which we're trying to beat today. But we can also tell if we've mispredicted by simply just putting an else statement here and being like, oh, we've mispredicted, and then we can render something different out, right? So that'd be quite nice to see. So, yeah, I was trying to think if this will crash and burn and die in horrible ways, but I think it won't. Right, it compiles, the computer says yes. The found hit, if you've only, you need to do found hit is true. The found hit is not even used anymore, let's get rid of that. Okay, let's try this thing out. Is there anything else that we use at the bottom? Right, you won't get your anti-aliasing. Right, so you need to do anti-aliasing as well. Yeah, that's a bit of a problem. To do, you won't get anti-aliasing here. Something like that. Right, let's give that a run. Okay, so we're actually slower. So we're not seeing any benefits. So if we were to change this and reduce it by some small number, does that help us, right? No. So your closest hit depth, you should be traversing. Yeah, I'm not sure why it's slower. Like, so you're doing this, right? But surely you're causing it to traverse less. So let's display this heat map. So what we should be seeing. Yeah, we should do that. We should add that debug mode. Right, so here's the... Right, this is interesting. This is different, isn't it? This is literally different. We've got holes here. Yeah, maybe the predictor's wrong for some reason. So then if we re-enable that, or disable it... Oh, sorry. The wrong code. Yeah, so you've not got holes in here anymore, right? Maybe just a screen grab. But we should be seeing a lot, like none of this red, basically, for a still image. Well, no, sorry, the still image thing was for the old design. This design shouldn't really need a still image. It will have problems on edges, probably. But these are big spheres. So we shouldn't be seeing these issues. Right, so if you look at this image, this is great, right? But the rest of it is kind of... I'm going to see if I can get... There we go. Like, the rest of the image is not really being affected at all. So let's do a couple of debug modes. So, what Moscow is suggesting is that we say color for a hit and miss. Yeah, so we want to render... So definitely want to know if we've mispredicted. Is there any other ones we could do? Predict. Show mispredict. So Boolean mispredict equals false, and we'll set this to not hit success. So when we put the color out, we'll just simply state Right, I think I have an idea of what the problem is. I think I know what the problem is, but let's just carry on. So if we want to show else if we're going to store based on a color of we just want to show, we just want to say if mispredicted, then render out a different color, and we'll just say make it red, like full on red maybe. Or we could blend red into it, but let's just make it full on red. We could also just invert the color. Invert the color might be easy, might be better. Nah. Let's just make it fully red. Whoops, I got the other one on. Stable heat map. Right, so the only ones that didn't mispredict are these guys here. So that's not good. Really not good. So how are we gonna fix that then? So I think in the prediction code. Oh, it's still storing the closest hit depth. Closest sphere index. Right, that was not what I was thinking was the problem. Right, okay. I was thinking this was being offset, but it's not. It is the proper index. Okay, so that should be a solution. Excellent. Right, so now it's getting good. It's mispredicting the edges, but that's what you would expect, right? You wouldn't expect the edges to be preset, like. Now another problem is that it's cutting it off by the bottom left more, but maybe that's fine. The way the down res is right, but you know, this is pretty cool. Let's keep it. This is the game now. The mispredict. Yeah, this is the rendering style now. Ship it. So if we disable that mispredict thing, let's actually see some performance numbers. Thank you, sir. Appreciate it. So it's actually not much better. So let's see why that is. I was expecting much better numbers because we're probably tracing against the same. Oh, I did a -1 as well and everything. Damn it! I expect to be hitting one sphere, testing against one sphere, and because I've tested against that sphere, I shouldn't have to traverse and hit the same one, and it should skip all the others. Let's make it 10 closer for some reason. Let's just see if that makes it any better. I'm wondering if it's something to do with that. Right, that's definitely made it much a little bit better. I'm starting to see more artifacts though. You're seeing chunks taken out, but that's obviously not correct. You're seeing chunks taken out the edges, especially on the left. So it's not to do with this per se. Um, so is the problem that we're doing a like doing another test? Right, because at the moment, number of boxes visualized now. Yeah, let me put the epsilon back. Right, so this is the old one. Karita. Wow, really? Something's fishy there, isn't it? Or is it? Ah, okay. So we test against this sphere. It hits this point, which is inside the box. Right, so this is not as effective as I thought it would be, thinking about it. So you've got your box. Let's see if I can draw it out. So you have like a box, and you've got a sphere in there. Your ray comes and hits this point. Let's do that. Sorry, the other one was actually perfect. Right. So you come in and hit this point here. Technically, this point here is inside the sphere. Right. So when you have your layers of BVH that wrap this bugger, right? Maybe this is the extent of that it's, you know, something like this or whatever. And you've got tons of other boxes or whatever. You still have to traverse through these layers, right? For these pixels, right? I was thinking it would have been right. Yeah. So technically the only ones that benefit are these guys here. Bounding sphere might be better. We tried the bounding sphere out last time. The problem with the bounding sphere is that for horizontal or vertical shaped objects, you get a massive sphere. So it ends up being worse, basically. The boxes handle very, yeah, they're just better. The only thing they're not good at is their sharp edges, right? If your object is square or cube in 3D, then a bounding sphere is better. But if it's wide or tall, then no. So I don't know if this prediction route is actually going to be any good, basically. Like, you're definitely going to help skip the ones behind it, but then again, you're going to be favoring the closest ones anyway, right? It's as if you need to, but maybe we could store the closest hit bounding box instead, right? Maybe we store the closest hit bounding box of the sphere that you hit, right? Yeah, we store T min of the box and not T min of the sphere. And then we use that instead. That might be better. Yeah, that should work. So we'll store T min of the box instead of T min of the sphere. So we've got to go back to using a float, and then that removes the extra sphere test. But then again, you're getting a downsampled low resolution version of it. So technically, you could actually be off, right? Yeah, that close to each other, you would, wouldn't you? Wait, spheres that close to each other. No, because they'll be in the same box. There's two spheres together. Wait, closest sphere of the box. You're saying skip that. That's the closest hit. Yeah, it's a different thing, isn't it? Yeah, yeah, that's not right. That won't work. But you'll get too many glitches with that. Because if by that logic it would work, you could also apply the same logic to the traversal code, right? Rather than using the closest hit on the sphere, use the closest hit on the box. But then you would get glitches from that because the sphere could. The sphere that's next. Like you could have hit you could have like a vertical box, for instance. You've hit this sphere, right? But you've used T min here, right? But then and then you'd right, and then you could probably have another box which overlaps it for some reason. Or would you? Maybe have another box where you've got another sphere there and a sphere here for some reason. And you do this. Yeah, it might be fine. It might be okay for our problem though. Draw a lower sphere so it intersects with the array. Oh yeah, from here, this one. Yes, this one will be inside of a box, right? Yeah, I don't know if our problem set is going to be destroyed by this solution. We can test it by simply disabling the prediction code and just running it. Yeah, it might be fine for our problem set. This would be interesting. Let's explore it. Let's disable the prediction code. Closest hit. Where's the bugger? So the hit is in between the faulty predicted sphere and its bounding box. But yeah, no, I'm just thinking about just picking the bounding box that you're in and using that closest hit there. We'll see. Closest hit, ABB depth. Let's just give this one a go. So it's this T min, right? So imagine if you just did this. So you've hit the sphere, right? So only when you've hit the sphere do we try this. So this is when we traverse down. Let's just see how this will look. T min element is less than. So the new box is closer than that box. I don't know. Have a gander. They're all disabled. Right, let's try that out. Let's see if we see any glitches or artifacts. Right, we see absolutely nothing. That's the best artifact we've got. Starts off at infinity. Oh wait, but only when we hit the sphere, isn't it? Sorry. Here. Let's try that. Yeah, we're seeing glitches. It's actually not made it that much faster. I wonder what it'd be like with the prediction code though. Yeah, we're seeing glitches. Uh-oh. We're seeing that one all the way right back there. That ain't good. Why is that? They're probably inside of each other. Yeah, it's probably not sort of an issue. It's to do with how we've just basically decided we've told it to skip checking a box. Yeah, that's not a good solution. Right, so I don't know if we can extend this one anymore, really. Like, let's go back to the thing we're trying to do. Enable the prediction, show the heat map. So the prediction, basically, again, it's only wins costing us more right now. It's only, like, it would be great if it was 8 pixels by 4 pixels, but had many of them. It's probably got like a bounding box around the thing. Anything else you could do? Like it, and the reason why it doesn't help skip the ones behind, because it would always try and go down the tree, you know, hit the boxes that are closer to the camera. It'll hit both boxes. It's a binary tree, it hits both boxes left and right and chooses the closest one and repeats that. So you don't really, like, that's already a good enough of a win as it is. That logic. And we don't really help, we don't stop the whole traversing down the tree logic with this method, unfortunately. That much. So maybe you can get it to, like, when you hit this guy, and that's your closest hit, it's as if you want it to skip trying to test this box anymore. Maybe. But then if you have two spheres, no. They're close to each other. Not really. Two spheres that are close to each other in the same box that animate and maybe go over, you get some artifacts. Yeah, I don't think this solution can work actually, which sucks. Right, I'll leave the code about, but I'll probably remove it. Just in case we think of any other ideas. Right, so what were the other ideas? Dynamic LOD. So this idea is basically just test. So it's good for small objects. So you don't traverse down the whole tree. Basically, right? So the idea is, hey, I've hit these guys. Can I go down anymore? So the answer would be something like if, do you get the F32 times 3 AABB dims, subtract the ABB max with ABB min, right? So that's the size of the box. And what I want to do is just say render the box when it's like 4 pixels or something like that. There'll be a number. So I think I just want to do like a min element of all of the whole size or whatever. If that is less than, now we can, if we take t min, multiply that by, where is it? So this test, to be more precise, we should really bring it back into the near clip plane and, you know, see how big of it is there. But the problem with that is that it involves dividing. Or does it? Yeah, it involves like division and stuff, I think. Maybe there's ways around it. But we're just gonna go the other way around. We're gonna take a pixel and see how big it is at that depth. So I've got a pixel on the near plane. There you go. Pixel size at near clip plane. So we multiply that by the depth, it will take us to what pixel is at that depth. So pixel depth times 4 pixels, whatever. So if you're sort of about 4 pixels big, we're just going to say, hey, render with a box. Just render the box. So we'll set isLeaf. So this is a bit of the problem with all the damn branching everywhere. We essentially want to say we're not leaf for that statement below. Have another boolean to say yeah. So we want to say isLeaf equal. This is really bad. Test spheres equal false. Something like that. Yeah. So now you want to just color it in, right? So what we should really do is like the axis line bounding box should have a color, like an average color now, right? And then we should probably calculate some normal. We can do that by just getting the hit point and seeing where it is from the just get a hit position and take it away from the center of the box. Something like that should be good enough, but let's just ignore that for now. Let's just color it red so we can see it in action and just see how much better it actually is in terms of performance when we go for smaller objects, right? So the hit depth is tmin element. Hit normal, let's just make it a 1 on the x. We're not really using that right now, but we are a bit. Right, see how much this works. So when it gets small enough that you should start seeing red objects, basically. There we go. Look, it works. So like, in terms of performance at least, that's about 1.7. Sometimes it goes to 0.2. But it doesn't really get any better. Yeah, I was expecting that to be much better. But let's bring it up a bit. Let's make it, I don't know. 16 is probably a little bit too big. It's probably 16 pixels. But we should see it trigger earlier. There we go. But yeah, you see, it replaces the sphere with a box, right? Yeah, it's not really making it that much better. To be honest. But yeah, I imagine like if you have, yeah, it's probably not going to be a good idea. I imagine if they were small enough, it might be okay, but it's might minimize the amount of visual artifacts, but it's really not helping out with the performance, which is kind of a shame. Wait a minute, let's just think about it. So it would have set is leaf to true, then it wouldn't have, then both children wouldn't have been set, and it should have skipped it, right? Yeah, it would have just skipped it. Okay, so ain't a good idea either. Okay. So the other idea is to make the number of spheres configurable. They're currently hard-coded to 2. So this probably... This stems from the fact that if you take a look at the spheres, some of them, like when you hit the pixels that sort of overlap, this one, like this box here, this is the prime example, right? You're hitting, when you hit these guys, you also going to be testing against these guys, right? Because this box is basically in the same place. So you can get rid of 2 checks for a bounding box, for the 2 bounding boxes, basically. The parent bounding box and one of the siblings. But this one's another case of it, right? Maybe, but maybe not. There's some overlap. Yeah, there's definitely overlap from about here-ish. Right, it's quite a lot of pixels that will hit both. So, potentially a better idea. You have a less deep. By having more spheres, you have a less deep tree, but you have a cost of, when you reach a leaf node, having to test more spheres. Right, so there's that trade-off to make. Yeah, this is a weird example. That ain't good. That's not good. Does GPU do latency hiding for compute shaders? Yes. So the in terms of latency hiding, a compute unit will have like 10 different compute shaders it can keep track of, 10 instruction pointers. And when it encounters like something that'll take a long time, it will put that shader on pause and it will go and do another one. So it basically pre-allocates a bunch of registers, each one that's running, and so it can save the state in the register. It just keeps the registers around so the state is saved, right? And it will pause it on the instruction, basically. Right, so we've got to find a whole bunch of 2s and replace it with a constant. So spheres in leaf node. So currently 2, but let's make it 4. So let's look around for our magic numbers 2. So when we generate our... It's all to do when we build the BVH, isn't it? So it should just be in the BVH. But what about when we construct the... I don't know. Anything to do with a 2 here? This one we just put in a 3D volume and SDF discard. No, there's no 2s there, right? So it's all in the no. Telling lies. Here. Number of leaf nodes. There's a 2. Hey Raymarch. Do you have any stats on how big your register state is for your shader? I've actually reduced that. Or registry state. I'm not sure. Do you mean register? I've reduced that number down. We did that last stream. We basically like took it down and we tried to take it down even more and it didn't help out. But yeah, so we got a good win from that. Does anyone know a better source code than OpenGL spec for 140 works? Yeah, the wording is ambiguous. Don't worry, I got you back. And it's in Rust. There's a crate for that. Didn't you know? Didn't you know? Look here, a line. Bob's your uncle. I know, right? I wasn't trying to troll you, by the way, very much. This is legit. So it solves the 140 thing. Just check what they align to, and Bob's your uncle, right? Even for float line 4, they've even got like array of them as well. Where is it? Yeah, the problem is arrays. What does it do for arrays? Did it do that right? Here we go. Yeah, the wording is super dodge. So I did look in the source for that. They make things align, but they explain... Do they explain why it works and what it does? Yeah, so in here, they also say the array as well. You have to use that special array type. Because the arrays, you see, if you have an array of float in standard 140, they actually stride by 16. It's really bad. Maybe they explain it in here. There's words. Yeah, they've got an array thing as well. I'm sure they stride it by... There you go. All elements are aligned to 16 bytes. Do I use any Rust? No, I used to program Rust. I got the initial hook in the 0.8 days, and I kind of stopped about 1.32. So I've been programming in it for like 4 years, and before there's all the hype around it, as well. And I also witnessed the hype coming and stuff. But it was pretty cool. The only problem is I had my own standard library, and I had, um, you know, I was finding more and more that the borrow checker was literally just getting in the way. And then I went back to C and then just realized how simple it was, and wonderful. It's complete and correct. Yeah. Well, there's that one, isn't it? The only way you can do it is test it, right? Write some test case, and see if it works. Like pull the data out and render an image red, right? If it's correct. And test all the edge cases with arrays, floats, and vectors, and that's it. I'm not sure if there will be. Should be fine. Right, so times by 2, take 1. That's not because of the number of elements in our leaf node. That's just the way you get the number of BVH nodes, so you don't change that number. Any other 2's dotted about? Yeah, 2. No, that's fine. That's just a 2, I swear. Right, so where's the... Let's get past all of this. The UI code. Calc bounds. Let's go to you. Right, this is our BVH building code. So, how does one build BVHs? These are such bad variable names. What is TTT again? I was jamming this code in. So, damn it. Number of nodes, take 1 divided by 2. Right, that's the num_leaf nodes. Right. So you got 5. Two seconds. Right, it's got 10 nodes. So you got 10 nodes. 10 take 1. 9 divided by 2, right, is 4. What is that? Is it meant to be this? It might be that. Take 1 divided by 2, 1. Oh no, it's 5, isn't it? Oh shoot, 11. Damn it. Right. Okay, 11 divided. Right. So that's your leaf node start index is getting. Okay. Good. Right, more readable now. Good. So anyway, I'm going back to that code again. I've got 2 in there. That's not numberables. This is numberables. In the balls go. Now this could be So we could pad it. I'll do a for loop. You probably want to min base sphere plus that, min, right. Times 3s infinity, and then negative infinity. So we need this instead. Then it's just that. Okay, so that sets up the leaf node. Right, any more 2's dotted about that we can replace with this spheres in leaf node. There's a 2 here which does... Right, this was for the old... Right, this was some sorting thing I was trying to do, but failed. With... That's just the left and right, that's fine. On the binary tree, this is where the spheres number goes. Right, so here we do the same thing, that sort of for loop again. There's another 2 that needs to be replaced. Right, so this is the prediction one, actually thinking about it. More. So here's the proper shader where it does all the bells and whistles. Right, I think that's it. Why does that times by 2 again? Oh yeah, because it does 2 BVH things. It's quite obvious. Hit depth. Yeah, that's the BVH traversal. That's fine. Okay, that should work. Min this and BC spheres count take 1. No, spheres count. No, take 1 in there. Boom. That should be it. Nico, appreciate it. How's it going? Welcome, raiders. How we doing? Thank you for the raid. How did the stream go? There's a sentence about padding followed by ambiguous mention of base alignment. Right. Yeah. The wording is absolutely horrible. Like, it's just standard Chronos, basically. I remember reading it many times myself. Hey, Sigma. Did you consider using BSP trees instead of BVH? Is BSP a relic at this point? Binary space partitioning. The problem with binary space partitioning is that it's like, so the BVH is that you get to basically to define the size of that binary space partition, right? But it's not necessarily like so the advantage of the BVH is this, right? You've got a box, and you got another box there and another box there. In a BVH, like, so this is the outer, and these other 2 are the inners, right? Whereas in a BSP, you'll probably put a partition here or here, basically, right? Yeah. So you'd have more rays that can miss, right? Sorry, in a BVH. That's the idea. It might cost a little bit more though to test, but it will be cheaper in the long run, I think. Just random stuff, working on GCLI, and people distract me, fair play. But yeah, I mean that I cloned out the Minix source code to explain something. Sounds like the everyday type of stream, you know? As you do, just clone the Minix source code. Oh, good news, GCLI is now Debian and unstable. Amazing. Very cool, nice achievement. I haven't got any more source code into anything. Just probably some AI copilot thing or something. I don't know. About it. Right, if the stream goes down, I'll be right back. But it shouldn't do. Right, we're still running. And it's running faster. Ugh. Negligible though. So we've been proven correct. 4 spheres in the base node has ended up better. How much better? It went from 0.72 to 0.78. It's kind of going to 0.767 as well, but yeah. So it's like 0.04 better, which is like the equivalent of clearing a whole screen of pixels. So yeah, so what happens if we put 8 children there? Right, so let's put 8 children in the leaf. Because technically, if you have, we're doing the Morton Z curve, right? So technically we're doing a 3D Morton Z curve. Let's get this looking 3-dimensional. How can I draw in 3D? I'm just trying to picture it. Something like that. So that's coming up from the bottom. Right. So that's just made it even more confusing. So this is the bottom one. This Z is the bottom Z. This Z is the top Z. So technically, if we have stuff that's partitioned 2 by 2s, right? X marks the spot for a sphere. You know, so these are where our spheres sit, and that's 8, right? 2 by 2 by 2. So technically, if they all sit next to each other, we could get them all in a box, and that could be a 3D box, obviously. And theoretically, that could be better. But the problem is our data isn't going to reflect. If the stream crashes, I'll be right back, but it shouldn't do. Right, we're still here. Right, that made it a bit worse. But theoretically, like, if we were to have an 8 by 8 by 8, you're most likely going to test the 8 spheres anyway. Just trying to find a good example. But they're not going next to each other because it's not a perfect. Like, we should basically, if we get a gap in the Z curve, we should cap it. Put it that way. I don't think there's a good way to do it. We should basically be able to have some empty spheres. Not sure if it's a good idea or not. You should be able to have some null spheres inside some child nodes. And then that would mean that all of the base spheres will literally be square. Which could be better. And there won't be these odd shapes. And maybe a bounding sphere will be better in that case. But maybe not. No, this square, it's better off being probably a box anyway. But yeah, because you get silly stuff like this at the moment, right? This is dumb. Like we don't want this. What would be better is if we had probably another layer of nodes that split this up better. So you want a 2 by 2 by 2, right, which would be 8. And you just want to box around those 8. Right, and if there is an 8, then put the box around those, those ones there. So we should really do that next, I reckon. That would probably get us a speed improvement, and we could probably do 8. But maybe 4 is better in that case as well. Hey man, is there a tutorial or to go from console to basic GUI shapes like a circle and a rectangle in C? I'm not sure if there's any, like, it entirely depends what you want to learn, right? Because to get graphics on the screen is in 2023 is probably one of the most complicated endeavors that you want to do in computer science. Like it's overly complicated for no reason. So if you want to learn to sort of like just put stuff on the screen and have a bit of fun, you've got Raylib. Like Raylib's a nice simple API that allows you to literally just put stuff on the screen, and you can sort of learn to make games nice and easy with it. It's got tons of examples here. You can just put boxes on the screen in 2D, and you can also do 3D stuff as well. And you can just sort of get a feel for things at a higher level with Raylib, because it does all that low level plumbing stuff for you, right? Yeah, I think that was probably the best sort of suggestion, given the where you're coming from, I guess. Yeah. What's on Frisbee? Awesome. So yeah, the best thing about Raylib as well is it's got a big community, and they also have tutorials you can just click on and see the code. And you can also play with it in the browser, I think. Yeah. So you can see all the example stuff and have a play. Yeah, highly recommend. Right, I'll be right back because I need to get another drink. But we're going to sort this issue because I feel like this could give us big gains. So we're basically having a variable number of leaf spheres and leaf node, but they're going to be square. It's going to be amazing. Right, BRB. Right, welcome back everybody. So we've got to find a way to yeah, so when we initially build our spheres array, we need to put in, it needs to be a Morton Z curve. Rather than sorting, we're just going to plot in Morton Z curve order. So when we take our spheres, we just have a, yes, the problem is you have a lot of empty nodes in this with this solution. Hmm. Yeah, okay. So I was thinking about maybe just doing a base array where you basically just store it for the whole. Let's just do it in 2D. Imagine you just have a 2D space. Every pixel, in a sense, is where a sphere goes. And you'll basically just store each sphere in there, but there could be empty slots. And you basically just wrap the box around those spheres. But the problem with that is you could have like you could have a lot of empty space, which means you'll have a lot of empty nodes, which is not good in the tree. So we probably need to tackle it from a different angle when we build the BVH tree from the leaf nodes. You'll be going over them in order, but then it's multi-threaded. And you kind of want to grab... It's ordered though. Yeah. Okay, so when you build... Yeah, I think this is where we've got to do it. So you build your spheres and you need another array which tells you how many nodes. Maybe not another array. You need an integer which tells you how many... yeah, you need another array. So 2 arrays. One will be the spheres, the other will be the number of spheres in your leaf node. Something like that. So you got your spheres, you got sorted spheres, there's the sort keys. Alright, here we go. Here we go. Okay. So we're just gonna do another array. G spheres, G leaf node, nodes, spheres counts. Leaf node, sphere counts. That's it. So I think that'll do. Let's make one of these. We'll upload that to the GPU as well. It's one of them. So basically, while we're doing this, you want to know when you've jumped to the next 8, basically, right? So you have a counter. And you're just going to say, right. So you do... No, you know already. Counter, index, and then you have a counter. So basically... Right, where are we doing this? You want to say every 8. Is it when you land on the 8th? or just the one after. Yes, after you say if index plus 1 mod 8. So it's a multiple of 8. Well, it's not really. It's if the there's the Morton index. Yes, if that Morton index is in a different multiple, we should be able to do this in another shader on the GPU. If we sort them on the GPU, we might be able to do this on another shader as well. But we just need to, it'll be a different algorithm, obviously. So if this source index divided by 8 is different to the multiple index, we simply... So, is it plus 1? So this will start for 0. So counter multiple index, I guess, equal to this. And then we want to reset the counter to... Right. It's better off as leaf node index, that name. So G leaf node counts, leaf node index equals 0. Okay. Right, I think we're getting somewhere now. So we start off as 0, the first one, and then every single time you come into here, so you could be out of bounds actually thinking about it. So you're probably best doing the check right away. So then you up it by 1. Okay, so you go over all your spheres. If your leaf node index is different, you update it to the new leaf node index. Reset it to 0. Thing is, you've got to set them all to 0. You just got to do that. Core 0 element many pointer how many spheres cap. So a bunch of zeros. Because could you still have zeros? Yeah, you could have stuff with 0 elements in there, I guess. You can still have leaf nodes that are empty. But hopefully it's not that bad. Let's see how it goes. So you'd up the leaf node count. And this would be in order. And when you're part of the next 8, yeah, I think that's fine. So we've just got to upload this to the GPU now. So let's follow this through. Wait a minute, shouldn't this be uploaded to the GPU? Oh, it puts into spheres. Right, I don't need the G's then. Damn it. Alright, let's get these buggers sorted out. So we need a new upload. Leaf node spheres count. We need buffer. Leaf node spheres counts. Okay, sphere counts. Thank you. Oh. Ta-da. Yeah, so just need to make that leaf node spheres counts buffer. Leaf nodes node sphere counts. E32. Right. So this gets cleared to 0, set up like so. Okay, so you kind of want to pick a max probably, but that's fine. Just test code, doesn't matter. So that would be good. So now you just need to use that inside the calc bounds shader. So calc bounds generates the BVH. So yeah, should be fine. So we actually need to use the leaf node spheres count buffer. Right, so we need this boy in the okay. So now we can use this in the shader. Just need to synchronize on it though, obviously. Okay. All good. So let's go ahead and use that in the shader. So inside the shader, crap, you don't know where the start index is. Dun dun dun. So before we rename it, let's just test it all out. We'll cram. Well, yes, 24 bits we'll just use for an index and 8 bits for a. Well, we only need like 3 bits probably, but for a count. So basically, you're just going to store. You store them in the low bits, and you can just increment it. It'll be fine. So what you want to do is store in the high bits. You do your where your start index is, right? So your start index would be, because you're putting in index, isn't it, right? Yeah. So it's index. Yeah. Shift right 24. And then you can just increment, because that's in the low bits, right? Technically, we could probably go all the way up to 29, but 24 ought to be good enough for now. Wait, let's do 29. Yeah, you got 3 bits, good. So, because 3 bits gets you 0, or it gets you 0 to 7, so you might need extra bit. Okay. So what you can do with the counts is you can get them out here. So you can go, oh, what is my base sphere index? So you've got your leaf node index, right? So you just want to get this sort of like, I don't know, let's call it N. BC leaf. This one here. Put the leaf node index in there. Done. Bear in mind, we probably want a minute just in case, you know, what the GPUs are like. Crash and burn. If it's anything wrong, so let's just, was it leaf nodes count? Is that passed in anywhere? No. Should be fine. Right, so you get this one out, and basically your start index is shift right 24, and then your the count is the first. Thing is, we've got to store the number of, we've got to store these things in the leaf node itself, the BVH, because there's no way that we can get there. There's no way we can get there now, because we're doing a variable number, which is fine, right? But it shouldn't be too bad. We've ran some numbers. I think this is fine. So in here we'll store that. Let's just call it N for now. I can't be bothered with the names. We'll patch it later. So we just want the first 4 bits, right? So the base sphere index we need that as a variable anyway. And you got the spheres count in that. Jobs are good, and so that should set up the. Let's find where this is. So this is fine here, number of leaf nodes. That's fine. So you could have nothing, and you've just made infinity, and that'd be really bad. So how do you solve that problem? You want to say if n. All right, let's just get its spheres count. If spheres count equals 0, then we want to make min 0, max 0, yeah? Yeah. So we've got to store in the tree that n value, right? So we'll just call it n. We can store it in the tree here, and for the rest, for the non-leaf nodes, it will just be uninitialized. So you just say n equal n. Okay, that's the setup there. Now, when we get cool. So we land this is the prediction code, but we'll sort it out as well. So you have the base spheres. This is actually going to be whatever the node is. So it's BVH node dot. Is that right? Yeah, BVH node dot n. And we'll shift right 24, and then we'll do like a spheres count, which is the and low bits. So wham that in there. Right, so that should be what we need to have 8x8s clumped together and get cube boxes, right? Hey, Maybe Dragon, thank you. Appreciate it. How you been? What is going on? Base sphere. Did I spell spheres wrong? Oh, spheres, sphere. When to plural, not plural, eh? Okay. So, this could probably crash and burn the stream, so be wary. I'm good. Currently reading about steam locomotives. Nice. Yeah, not bad, not bad. We just tried like 4 things today, and we've basically got very negligible performance increase back. That's just the way it goes. I thought we was going to be on good. We tried to make some code branch this. We made it basically branch less, right? Less branching, and it was very negligible. Like basically nothing back. So it was as if like the optimizer was doing the job that we'd done. But we tried to do some. We basically learned that packing. It's better to have a couple of booleans instead of packing it into an integer. Packing stuff into an integer is actually more expensive than a couple of booleans. No, it's GPE. We tried to predict the closest hit. Turns out there was something I didn't realize where something to do with the BVHs, and yeah, it wasn't like it was only good. Effectively, we had a box. We predicted the closest hit, and it was only good for the hits that are sort of here that touch the edge of the box. And I was hoping for the prediction to be great to avoid us traversing through all the layers. But it stops you traversing through all the layers only for these pixels here on the that literally touch the box. So it wasn't that great. This LOD thing wasn't really that good either. It doesn't really do much when the pixels are so small. For a BVH, it doesn't really help. Now we're on this one. Make the number of spheres of leaf nodes configurable. So we've kind of done 8. But we're trying to make it even better. So it used to be 2 spheres on a leaf node, so we made it 4 and it was better. A very little bit better. But I think we can make it variable now. And we're making it so you can have at most 8. And it'll make the boxes square. Sorry, cube. A cube, right? And it will always make them a cube, the leaf nodes. So this could be beneficial because you have less massive boxes. So yeah, fingers crossed. You won't have any 0 ones actually. There won't be any that are 0. Yeah, this can work. You would never have any that are 0, I just remembered. Never have any. Because we'd always count just 1. Yeah. Right. So if the computer blows up, we'll be right back, but it should be fine, right? Let's go. Okay, so currently with something's up, right? I don't know why we're seeing these big boxes. Like, what's up with that? Are these? Why are we seeing? I would disable the. Interesting. That was for the. Oh, did we do shift right 24 like a melon? Instead of 28. Damn it. Right, there's probably the issue. Right, we're only seeing one thing now. Not sure why that is. Oh, damn it. I shifted right by 28. I meant to only shift right by 4. Whoops. So I basically erased all of the bits. Okay. Hmm. Um... And 0. So yeah, that's fine. Um, do we need the leaf node index anymore? This is better. Now that we store it in the thing, we have to calculate it. We could have just fetched it from another array as well. Right, we could have fetched it from a different array. Okay. Right, so the thing that I find weird now is we're not seeing the full tree. Yeah, something's definitely fishy. It's to do with either the way we're calculating the way we're working everything out, or the way we're storing it in this array here. That seems fine to me. Okay, so let's go to regenerate it. Don't do this code is the problem. So we clear them all out to 0. Right, it's not doing the first one. Um, so we start off at -1 or U32 max. You do a source index, that's the Morton code index. So it'd be in the Morton order. Hmm. Yeah, something's a little bit off. Yeah, it'd be in Morton order, wouldn't it? Because it's sorted. Maybe that helps. Let's see. Nope. Um. Hmm. If we look at the data in RenderDoc, there's probably another way around it. We should be able to see it every frame. So we want to look at something like resource. Which one is it though? That's the question. I haven't got any debug names, damn it. If we go into the pass with this one, this is where we're building the BVH in. So there should be a couple of buggers in here. It might be easy just to print out the data, not gonna lie. So let's just do that, right? We'll go over all the leaf nodes that we've found. So leaf node index. And we'll just print out something like that. And we'll just say, number. And you probably want to print out let's read the counts out. Let's call it n. So n at that, and n shift right 4. So you just want to print out all the count of them, and then you go over all of them, print them out. What are we printing out? Bunch of comma separated. I'm gonna print out the spheres, isn't it? So you've got a start index. Base index plus, we'll call this II. Just gonna repeat. Okay, then we'll put an exit out so we can sort of just see that information. So it should be 207 of these guys. Much easier than viewing it in render doc when it's all CPU side anyway. That's not 27, right? Sorry, that's not 207 nodes, that's more like 27. Why? Like, we expect this to be... Well, maybe we expect 104 of them or something. It's 207 spheres. So let's just print out leaf node index. Every time. See what happens. Right, it repeats. That isn't what we expected, right? I thought this was like the Morton index. Oh shoot, I wasn't using the Morton index, was I? That's in the higher bits. Okay, we'll get that one out. So Morton index, that's a biggest problem. That's the sort information. So it's this shift right 32. That's what was missing. Alright. Okay, so with that, look at the data now. We'll see the Morton index will be in order. Why is there 2,000 of these nodes? They ain't right. Oh, those got quite high. Yeah, I think that's fine. Because it goes X, Y, then Z, I think. So maybe that's just as it goes down the Z. Something like that. Yeah, that's not the correct... This isn't correct the way we're assigning the leaf index then. So if we just get a different one, it should just up it by 1. That's probably it. So probably want to say every single time this is a mod of 8. Every single time it's a mod of 8, set your leaf node, up your leaf node index by 1. So we'll set this to like -1, right? Set everything up and then go. Okay, I think that's gonna work out. Shoot. What do we get? Sig action. I think we've got buffer overflow. Damn. Right. It might not be set. It might not go into here first time. Why are we seeing only like 23 of them? Okay. Last molten block. So we'll put that as like -1. If that divided by that is not equal, then we up the molten block to that. +1, so it happened the first time. Happened the first time as well, that's fine. Let's try that out. Right, that's better. Didn't we expect more though? And also, what are these all doing in here? They're all the same. Whoops, that's the wrong way around. Okay. Something like that. Wait. Alright, that should be the better debugging code. Right, I think this is what we're looking for. Oh, we only want 47. I've just realized. We've got 207 odd divided by 8. I think this is correct. So we've got like 207 odd spheres divided by 8. Wait, it's not divided by 8. Number of leaf nodes. Yeah, it is divided by 8. Something's fishy still. Let's get rid of this for loop, it's done. Doing it all in line was better. So 0, 1, 2, 3, 4, 5, 6, right? This looks linear to me. Right, we need more leaf nodes now. This is the new problem. The number of leaf nodes is actually more since it's variable sized amounts, right? Okay. Okay. So now we've actually got 47. So we actually need to store this final one. So when you know the number of leaf nodes, so this guy here needs to be calculated dynamically. So obviously we'll make this on the GPU later. I should probably get rid of all this other test code. It's kind of in the way now. This thing will create. Starts off a 0. Well, technically it should start -1. This looks pretty promising, not gonna lie. So let's look at that again. Oh, that looks fine. So let's swing into the game. Hopefully the game doesn't crash. If so, we'll be right back, but it should be fine. Alright, we're back. Now my performance numbers have been completely toast, been destroyed, because we've got so much printing in the way. Alright, we're better, people, look at that. We've actually increased performance today. Oh. So with this new method, it's gone down to 0.55. Now that's great. So we've got a overall today, even though it's been a bit long, we've gone from there to there. Right, 30% better. So that's been a lot of failure today, but we've actually finally hit success. So this was failure, failure, failure. This was kind of success, but we took it even further and made it proper success. So we've now got a variable node system. Variable number of leaf nodes, and they're all boxes at the bottom. That, oh shoot, they're not. Yes. Wait a minute, what is an 8 by... We might be able to make this even better. We've got to investigate our data. No, this is not what we wanted. But somehow it's a better tree. Somehow it's a better tree. It all looks like it's there still. Something fishy. We should have a bunch of guys like this. There we go. Bunch of these boys. 2 by 2s, so they're just a bunch of grids. Unless we do. Aha. Yeah, it's a very, yeah, this is fine. This is fine. So the leaf node is variable. It can be as small as 1, but it can go up to 8. But they have to be in the same 2 by 2 by 2. And if they're not in the same 2 by 2 by 2, yeah, sorry, oh, I don't know what I was saying there. Yeah, this is a good idea of it. So here's a 2 by 2 by 2. Obviously, it doesn't have these guys. These guys just don't exist, right? So that means your sibling is always in a complete. It never overlaps with you as a leaf node, which is pretty cool. So the siblings will never overlap. Unless we have any crazy stuff. Maths. Exactly, maths. Maths, mate. Have you heard of the surface area heuristic? Yes. So you can build a BVH based on that surface. Is there a bunch of empty nodes? What is this? Oh, that's because the thing's calculated wrong. Damn it now. Right, can we make that better? What the hell's going on? What the hell is going on? What? Oh, I hard-coded it to 206, like a melon. Sorry. So yeah, all the leaf nodes are variable size. So these are all leaf nodes. From here to about here, they're kind of leaf nodes. If they're less than 8, or 8 or less. So there you go. Looking good. Yeah, I've heard of the surface area heuristic. I'm not sure what to think about it, to be honest, because we're not optimizing our trees in any way. Right, we're not mutating our tree. But it might be similar thing that we've just done, I'm not sure. But yeah, it's pretty good. So, how close are we? That's the question. Yeah, so the old ray tracer, I've got to delete that prediction one, I think. We'll keep, yeah, yeah, we'll keep it around actually. There might be something we can think of, but I don't know. Right, so here's the old tiled one. We're going to render it behind. It'll render first. So we're just rendering twice the lot. So the old tiled one was 0.13 ms, but it has severe problems, right? We have a massive scene. It's got a fixed number of spheres per tile. Ain't gonna work. Also, it's not gonna work good if we were to cast rays from different viewports. You have to build a specific acceleration structure for each view, right? Which is a screen space tile binning. So it's about 0. Including the well, no, the bounds cancels it out basically. Yeah. So we're looking at about, it's about 4 times faster, thinking about it. Let's do 0.12. Yeah, 3.6 times faster. Is that right? No. Let me put that in. Yeah. So it's 3.6 times faster. Or 360%. Whatever way you're going to read it. So I don't know how much closer we can get to this in ray tracing. That's for sure. Can you do a hybrid version that tries doing tiles but falls back to the BVH if the tile is crowded? So you could make it a small list of tile, like. Yeah, I'm not sure. Because you end up doing both worst case, right? Which would be even worse. Like worst case, you're basically adding the two together. But yeah. Yeah. I was thinking, yeah, what we really need is to sort of like have a bigger scene. We need to have multiple of these guys. Also, let's enable the animation and see how bad it is, right? We're gonna see two on top of each other. That's okay. Oh no, we won't see two on top of each other. Right, so that's not made it that much slower. I was thinking the boxes would be so much worse. Oh, we're sitting on top of each other. Yeah, so the problem is the box is not perfect thing anymore. It has a bit of, but it's actually not that bad. That's all right. Okay. Um, so I think I want to try a different solution next stream. Next stream, what I want to try is rather than ray tracing, or we might technically still ray trace, but we might rasterize instead. Which means we get tons of overdraw. But I've seen people get incredibly good results with this. So we might rasterize circles, not spheres, circles, onto the screen. And we're just going to draw them on with like a for loop in a compute shader and plot every pixel. Now, this method will work really great for tiny spheres, but it won't work great for bigger spheres. So what I'm thinking is the stuff in the background could be made up of potentially, I'm exploring this. If the scene is really complex and we've just got whole worlds made up of these spheres and stuff, we might want a fast renderer that's for the background or for some really tiny objects. So we need to have some pass on the GPU which goes which one is big, which one is small, and sort of put them into the buckets. And maybe the idea of this small renderer something we need to explore at least. Where's the we should have a BVH. Switch. Why circles instead of spheres? Because then it will be cheaper. You can just do the scan line algorithm. Oh, sorry. What was it called? The you just use scan lines. I forgot what it is. It's sphere rendering algorithm, not sphere. Circle. Yeah, this Bree-Sunham's circle drawing algorithm where you get wait no, the midpoint one. Is that right? Yeah, this is it. The midpoint one, where you basically can do a quarter of a circle and repeat it on all the other quarters, and you can basically get lines. You can get a bunch of lines, and then you just have a shader which fills lines in. And if the spheres are really small, it's not doing a lot of work, and you can push more spheres, right? But the more spheres there are, the more overdraw you'll get, and it'll actually be worse. But I think for a bunch of background spheres, see, I'm not sure how good it would be. That's why I'm thinking about it. We might just be fine with a BVH, because the problem with two different rendering methods is if I do forward lighting, which I want to do with ray tracing, right? I'm going to have to do some form of lighting pass on that other method as well. So I don't know if it's a good idea or not. But yeah, so something like this for this one instance in the world, which is not a good test of numbers, but it's about 0.16 ms. If you add any more, it's not going to double or anything. But yeah, I'm rebuilding it every frame. It's pretty cheap. Building it is about 0.03 ms right now. It could be. We haven't tried optimizing it, to be honest. It was just really quick. We took some method from some blog and made it a lot more simple. But yeah. All spheres can be replaced with circles and a fancy shader. Yeah, I'm not sure what you mean by that quote there. All spheres can be replaced by circles. Yeah, like the whole reason why you want the sphere is so you get a projection. Like you want a projected sphere, right? So it's not a circle. It's like it looks like an ellipse near the corners. That's the reason why you want a projected sphere. But if they're really small, you might as well just render circles, right? Rather than doing like a raycast check, because it's just quicker to do the per pixel, just plot a pixel rather than doing a raycast check as well. But yeah, off topic on lighting. Did you see the Path of Exile 2 global illumination solution? No, I have not. Path of Exile GI Guy. Oh, was this the I saw it on Twitter. Was that the 2D game where they've done some interesting 2D yeah, someone linked a paper and it was like apparently stupid simple. I should look into that. I don't know why I skipped it. I think I saw the word paper and I sort of just looked away. You know what I mean? Yeah, it makes sense if you've got a fixed camera angle. If it's top down 3D, I'm just assuming fixed camera angle. Yeah, I forgot what they called it. I remember seeing it on Twitter. Yeah, if you have a link, and you find, or if you find it, oh, you got it. Wow, a YouTube video? You're speaking my generation. Right. Ah, Gen Zs be happy. Right, I need to adjust the setup so you guys can hear it as well. Gen Z, all the way. Is that loud enough, people? Sweet. Oh, TAA. I'm not a fan of TAA. I want to avoid anything temporal. Like, I know it's very hard to, especially when people do ray tracing and you get noise. But yeah, TAA would definitely helps. Or sorry, any temporal stuff helps with noise. But anti-aliasing, we're hoping to do that as we ray trace the pixel. So hopefully we don't need any post-fix AA stuff. Screen space shadows, huh? Hmm. Yeah, I saw this paper actually. You know what? I don't think I have time to watch this vid, but it's interesting. I can watch this off stream and I'll take a look at it. Thank you so much. Um, yeah. Um, right. So next stream, I'm not sure what we'll do, but it's either we're going to be adding more models, or yeah, see, we're adding more models, or we'll rasterize a bunch of circles. I've got to think big picture for a moment. I think I might lean towards more actually adding more models. The problem is with rendering a bunch of spheres for tiny distance spheres, if there's stuff in the distance, is we're gonna have to have two different rendering implementations, and you'll probably see stuff pop if you're not careful between the two different render modes. So hope, yeah, we're gonna see like how bad is ray tracing everything, maybe by just awesome, that's good. I like a mind-blowing vid. Plus, it's a video. It's so much better than reading some paper. Oh my days. Amazing. Right. Let's find someone to raid. I'll next be on Thursday. I'm only on for a couple hours on Thursday, but I'm sure we'll do some good stuff. Anyway, let's give TJ a raid, even though TJ is probably going to be ready to raid someone else soon. But let's just right. Yeah, have a good tomorrow and Thursday, guys, and I'll see you Thursday. If not, I'll see you Sunday. Right, catch you later. Thank you later.